Hey guys, Joe Pye here at Advanced Innovations. Welcome back to the shop. Last night I started working on part number 18, this little crank right here in the center. Now, as dimensioned, they're calling out for a 0.1 or 100 thousandths here and 93 thousandths on the square. Well, 7,000 of an inch doesn't sound like a whole lot, but when you put that together, it just, I just had to roll my corners of my mouth and flare my nostrils and say, what are you thinking? So I'm going to show you how it fits, and then we're going to make another one. It's going to be relatively quick. It's going to be an accelerated video with voiceover, and I will probably move on to making a pair of 31s at the same time. For those of you that haven't had a chance to see how that's done, that's pretty cool as well. Anyway, let's go over to the bench, take a look at how that shaft fits, or that handle fits on that shaft, and you'll see why I got to make another one. Let's do it. Well, there you go. That is a 100 square broach feature. It's about 200 deep. And that was a Z06 Corvette. You just can't beat that sound. Anyway, this goes right on here as the driver once it's all cut and relieved. But just can't do that. That's just not, no bueno, guys. That's sag. You know, you take away the G and you add a D and you got sad, right? So that's how it is. It's nice to test and play with, but at 100 versus 93 on the square, and this is to print, so is this. Just not digging it. So I'm going to make another one at 95. I can use the same broach, but I changed the gauge, and luckily I had some more material like this left over from a previous model. So let's go over to the mill, squeeze this in a specific setup, drill it, broach it, and then we'll start with all the relief cuts and rounds and such and make some magic. Let's do it. Well, to start the process, I'm using a pair of 1-2-3 blocks. I'm using one as a vertical reference and the second one as a clamp. All I'm doing in this operation right here is just cutting the end of the material off. You could also side mill this if you wanted to, but it's nice to have the part oriented so that you can do the most work to it in one setup. Gauge pin in the drill chuck gives you a quick visual reference of how close you are to center with the square material so that you can get an indicator in there and not be all over the place looking for zero. Once you register the face, make sure you rock the indicator back and forth to make sure the readings are consistent. And once you have one axis dialed in, if the part is truly square, that's just the number you look for when you move the indicator to the other side. Just simply shift the table until you have that number on the indicator and there you go. Center drill. The drill I'm using here is just slightly larger than the size of the broach. The broach is an 082. That drill right there was an 089. You can see the little moon shapes either side. It's a soft material, so it's not a problem with knocking the corners out. Walking the broach all around, looking for the size that I am shooting for. I'm not sure if this was the 95 or the 94. I do have an 095 gauge, but for the 094 I used a gauge pin, knowing that the profile was square anyway. It just wasn't worth making another gauge. And it fit like a glove. You'll see it at the very end if you stick around right to the end. I did want to sneak up on it, so I took several passes, making small adjustments each time, because the length of engagement is just too short. And the slightest little bit oversized is going to rock around. Okay, 95. Takes a 95 square gauge. This is 93. I still expect some movement here because of the length of engagement. You know, the smaller the length of engagement, the tighter it has to be in order not to move at all. So there is still some wiggle in that, and that is to be expected. But it's a whole lot better than it was. As long as it clears the top, clears the bottom, fits them both, we are golden. Let's stick this thing on a fixture plate, neck it down, finish it up. Okay, now without moving anything, I have established two very critical banking surfaces for the part I'm about to put in here. The gap formed by the cutter that went down in there. This is a 250 cutter, and it's a 250 gap in between. So I went about 55 on either side. Collectively, that is a 110 if these jaws were to close together. So I could squeeze an 1/8 inch piece of material in that channel that I just cut. I know that the center of this cutter is exactly 1/8 of an inch off this back wall. So if I move my cutter, which I will do right now, watch the cutter go that way. I'm going to zero out my Y-axis digital, or your dial, whatever you got. I'm going to go to 125. Go to 120. Let's say 124 and a half. All right, I'm going to zero the cutter. Excuse me, zero the digital. Right now I know that the center of the spindle is over this back edge right here, so whatever piece of material I put in there, I don't need an edge finder or an indicator to locate the feature that I want to do. And that's going to be a 1/16 hole for the small handle. I also know that the bottom of the cutter against that surface right there is 0. So when I drop the table, I can establish the thickness of whatever part I'm going to put in there. This is also critical. Okay, let's put that little piece of brass in there and see exactly how this plays out. If you're going to do something like this, make sure that the top of whatever sacrificial blocks you're using don't protrude above the jaw itself, or they're going to cantilever in and close in a V, and the part's not going to be very secure. So this is just about flush, and the channel itself is just about as deep as the part is thick. I'm going to lock it in there, and I'm going to leave it locked in there. The center of this part gets cut down to 43 thousandths of an inch thick. That's pretty small. Just over 1 millimeter for those of you that are wondering how big 43 is. So let's do it. Let's drop the table down 43 and call that the new 0 for the bottom of the cutter. For this operation, the cutter was brought down to a quill stop, so I can now safely raise the cutter manually without issue. And let's get that cutter right directly over that part. I'm going to put some visual reference marks on the part so I can get close before I start taking dimensions. Looking for a specific dimension from the end in, and I'm looking for a specific width of that particular slot at the depth preset by dropping the table. And having the setup like this allows me to go completely across the part into the aluminum. Not a problem. In this operation, I'm about 5 thousandths shy of where I want to be on the depth of this cut, and I'm just going to push right through the center of it, establish a clean surface on the left-hand side of the part so I can measure it and figure out how much farther I have to go in order to set my 0 and my shift locations. Knowing the diameter of the cutter and the thickness or the width of the channel to be cut, all I need to do is subtract the diameter of the cutter from the width of the slot and just move the table that much. I am not going to open these jaws at this time. I'm going to put the crank handle hole in and possibly use the tree pan tool that I used on the little mini U-joint to put the elevated round boss in this area right here. But right now that should be 43 thousandths thick on the bottom and 188 from the face to the inside, 625 across here to here. Next step after the pocket is to put the little handle hole in where the knob will go. Center drill first, ever so slight dimple. This is an 059 drill. Gonna go with an 063 reamer to follow. Half the speed, twice the feed. This is the tree pan tool that I used for the mini U-joint. And I'm going to just keep on going down until I can see a scuff mark on that nice clean channel that I have in the middle of the part. Might be a little hard to see on film, but when you're sitting right on top of it, you can see the little scratch halo. And the final element I'm going to do here is I'm going to reduce the height of that boss right there and remove the majority of this stock so I don't have to file it away. We'll go from there. All right, let's take a look at it. Still got to put the tapers on the side, bend it. Let's take a look, see what we got. All right, see, we're right there. Getting close. Let's do some filing. Bend it. Heat treat it though too. Definitely take a torch and light it up cherry red, make it glow, or when you bend it, it will crack. Been there, done that. Okay guys, I'd like to throw an inter-project note in here. I did make several of these, and on a couple of them, I left the end material on beyond the small round boss. And that proved to be very helpful when putting the side angles on. So if you can, since that boss there is a little bit shorter than everything else, and you don't want to shorten that after the part is relieved like this, leave the waste material on the end, then cut it off, then round it off. The sequence is much better that way. All right, now to put the angle on the outside of this little crank, I'm going to go tangent to this boss right here and tangent to the circle. 3-pin fixture. First cut here. Second cut there. Should be the same height if my math was correct. And if you do something like this, make sure that you put your banking pin on a surface that's not going to be milled away. That could really change things up a little bit. I will put a little push bar in here, and if I have to mill into that, so be it. Let's put it back in the mill and have at it. That is really hard to see, but I was looking for a tangent between that plane I just cut and the outside of this cone. And I think I got that. All goes well, all I need to do is flip this over and repeat this process on the other side, then we'll take a look at it on the bench. With both sides of this correctly angled and cut off in the saw to the length, the boss is there. You could file those little corners off right there to blend it in if you wanted to, but there's something that I want to try. So I've got this set up in the lathe, and I'm going to put a tool in the tool post, and I'm going to use it like a little bump shear, and I'm going to see if I can round that off with the lathe. Not running, of course, because that would be a little hard, but let's take it over there and I'll show you what I'm talking about. I know it's overkill, but I got to try it. Let's give it a whirl. The gist of this setup is the tool is set 90 degrees to the way it would normally be positioned for turning. That way, as it moves, It'll act like a scraper for the material that I want to remove. And I will be able to adjust the diameter of the material I remove simply by moving the compound or the cross slide in and out. Now this particular arbor that I have set up in this collet, this larger diameter is the size of the boss on this piece, and that little diameter is where the part's going to hang from. I'm looking through the camera, it's kind of hard to do this. There you go. And all I need to do is just set the tool up against that little diameter right there and move the carriage in and out, taking a bite each time, and I should be able to round that tip off just fine. Don't know if I'm going to go all the way flush. I could probably finish it with a file or rub it on some emery and get it right, but let's set the camera in there and take a look at this, see if it works. Well, I know it works, I just want to show it to you. During an operation like this, do not move the part until you retract the tool, or the part is going to have to be pulled off the arbor. Trust me, you'll see me do it here in a second. If you're blending two flat surfaces, make sure that the flat surface is positioned vertically with the face of the tool as your final pass, or you'll end up with another dig mark along the length of the outside of the part. Not bad, huh? I like it. Gonna move in just a little bit more. Push my luck just a hair. Finish it up. There you go. I think with minimal blending that'll turn out really well. It'd take a little bit more off, but why push your luck, right? Well, then again, why not push your luck? Let's do it. Well, that's not much.
Not worth pushing. I'm going to file from here. Then bend it. Let's do it.
This particular arbor can serve quite well as a guide for a file to finish the job off. Registering the file on the turn diameter, just apply very gentle pressure until the file flattens out, and you'll come up with a nice end on the part. So here we go. After heating the brass parts to a moderate cherry red, not too much, you don't want to go too much on it because this is real thin, it'll melt. This is 043 thick, just a little bit over 1 millimeter. This is the nest that I made to bend them. The top shim just simply anchors the top profile of the part, and the bottom one creates the radius and the starting point for the radius, sanded onto the profile of that particular shim. You do have to overbend it slightly because there is some bounce and memory in this material. But when you're done, and that's what you got. And I was lucky enough to have 2 of them survive this time. Last time I did this, I did not heat it, and they snapped right off. That was a real heartbreaker. And although this is not the component that goes in here, you get the idea what that little guy looks like when it's done. This will be steel. So there you go, an awful lot of work for another part that's going to be completely overlooked at assembly because it looks like it belongs there and it looks like something you bought in a store. Well, that'd be an awfully expensive part if you bought it in a store. So thank you very much for tuning in wherever you are in the world. Hope you're well, happy, and safe, all of the above. I'm Joe Pye, Advanced Innovations in Austin, Texas. I'm out.